So I said that I was going to talk a little bit more about the basic science behind the research that brings me out here to Rosario Beach Marine Lab. And so I want to take this time now to really begin to talk about the beginning of it. And it really begins with this thing called ocean acidification. And so ocean acidification is this other process that's happening because people, us, we are dumping more and more carbon dioxide into the atmosphere, and that's having really a lot of negative consequences across all different types of ecosystems. So this is one of the major ways that is happening, and it's one that we really don't hear about too awfully much, but is just as devastating as a lot of the other problems that we're having due to a ton of CO2. We're going to be talking a lot about pH in this, so if you're a little bit rusty on pH and how that works, I'd encourage you to go take a little refresher. A really good one is done in Crash Course. I'll put a link in that down in the description. Go ahead and take a quick look at that. But really the basic principles from that are going to be operating the same in seawater that we're talking about, even though it's a little bit funky due to all the solutes, all the stuff that we have dissolved in the seawater. So, carbon dioxide gets dumped into the atmosphere, and really we now know that a lot of it is taken up by this, taken up into the seawater. Somewhere between a third and a half of it is sucked up into the oceans. And for a long time, we thought this was a great thing to have happening because, hey, the sucking it out of the atmosphere, that's grand. But now we're figuring out that it's having just as bad of consequences in the ocean as it could be in the atmosphere. So let's talk about what's happening there. So we have carbon dioxide, which is this molecule right here, one carbon, two oxygens, carbon dioxide. And when it gets sucked up or absorbed into the seawater, it combines with H2O, water. So it combines with this. We have CO2 plus H2O. We have three oxygens here, two hydrogens, and one carbon. And it makes this thing with, again, one carbon, three oxygens, and two hydrogens. This is a thing called carbonic acid, and this is the principal element that is causing the oceans to drop in pH or become more acidic. Now, if you remember from pH, what's actually making things acidic is this lone hydrogen proton, this lone hydrogen ion. And so what happens here is one of these hydrogens easily pops off. So what we get is this hydrogen kind of coming off by its lonesome. Actually, it'll combine with hydrogen to make water to make a hydronium ion, and we get this oxygen with a negative charge on it. And what this is now, this is a thing called bicarbonate, and this is our acid. This is our lone proton that can then go on and react with things, and this is what's causing the pH to lower. Now, sometimes this other hydrogen will pop off as well, in which case you get this. Again, one carbon, three oxygens, and then you get these two protons out here off by themselves. Now this here, this is carbonate, and then we have these two protons off here. And this also can happen as well. This doesn't happen nearly as much as we get bicarbonate plus one hydrogen, but this happens as well. So this is what's really going on. Now, historically, we know before we started dumping all this carbon dioxide off into the atmosphere, the pH, the average pH of the ocean was about 8.2. If you know, that's a long ways from being what we consider to be neutral in distilled water that doesn't have any solutes in it. Neutral, the term neutral gets a little funny in seawater because we have so many things dissolved into it. It's not really so much of a useful concept as it is in distilled water. But really, that is 8.2, the healthy pH of the ocean. Since we've begun doing this, since we have been dumping CO2 into the atmosphere and that's been sucked up in the ocean, we have already dropped pH to 8.1. Now, that might not seem like a lot, but remember that pH units are essentially going as powers of 10. So that actually represents a 30% increase in this guy right here, in these free protons that can go on to react with things in the acid of the ocean. And if we continue on the course that we're going, by the end of the century, by 2100, we are predicting that the average pH of the ocean will get down as low as 7.8. And that's really low. Now, again, you might be thinking, okay, that's not that much. That's only 0.4 units pH. That's not much at all. But this represents over doubling the historical amount of this guy right here, of these protons, of the acid of the ocean. Over doubling. It's a 250% increase. Now, just to put this into context, if your blood, which is normally somewhere between 7.35 and 7.45 pH, if it were to drop 0.4 pH, this is going to put you on death's door, if not kill you. It's not trivial. This is a dramatic increase in the amount of acid in a solution. And so we're doing this, and that's happening just out here all the time as we speak. The pH is dropping. And so this is something we really don't want to see happen. And this causes another problem. So I was talking about this. We have this molecule called carbonate. And there's a lot of animals out there that really like carbonate. They use this, they pull this out of the water along with a calcium ion, and it forms calcium carbonate, or the stuff that clams make their shells out of, crabs make their exoskeletons out of, corals make their their skeletons out of. Coral reefs are built out of this. And so this calcium carbonate is really, really important. The problem is, as we build up more of these hydrogens, as we build up more of these protons free, they tend to like to bind back with the carbonate and go back to form bicarbonate. So we get an increase in the amount of bicarbonate in the ocean and a decrease in the amount of carbonate. And what this means is it's much, much harder for these animals to actually form their bicarbonate, or their calcium carbonate skeletons. And so this can be really detrimental on those animals. But really, this is just one of the easy to see problems of ocean acidification, something that's really easy for us to figure out. We don't know what's going to happen to most animals when we drop the pH by 0.4 units. We really have no idea. So what we're doing is we're doing this massive experiment on this entire huge ecosystem, the oceans, and all the animals in them. What in the world is going to happen when we drop the pH by 0.4 units? We don't know. And really, it's an incredibly hard question to answer, because it's not just involving one animal or this animal. It also involves the complex relationships between animals. For instance, imagine I'm a sea creature, if ocean acidification somewhat hurts me, we might think, oh, that animal is going to do worse. And that's a fair assumption. But if it hurts my predators more than it hurts me, I and my population of me might do a lot better. We can actually get off quite a bit nicer than what we were before. It's going to disrupt all these delicate balances that we have between all these different organisms out here. And we have no idea how in the world it's going to play out. And so that's one thing that we really need knowledge on right now. We need to start studying how this inevitable drop in pH of the oceans is going to affect creatures throughout the ecosystem. And that's where I come in. I'm really interested in what's going to happen to octopuses specifically as we drop the pH of the ocean.